retraced my steps to the antique shop. Lorraine's bracelet was still there, but the lamp was out and the shop had a deserted look. Where was Richard? Should I wait in the road or go into the shop?
Today we're going to be making an internet radio using an ESP32 and this lovely Roberts RM20. So thanks to a wonderful tutorial by Nick from Educates.tv, it looks like this might be a fairly simple project. He says that before he's even done the project, but this is meant to be a from start to finish project, so you're going to get to see how difficult it is. Now what I've done is collected all the bits, so we'll talk about this again in a second, but let's have a look what parts you need. So starting off, you're going to need an ESP32, you're going to need a VS1053. This is an MP3 decoder made by VSLI. The chip is the 1053. This is just a little dev board. You're also going to need an amplifier. I've chosen the PAM8403 because it's just my favorite little amplifier board. And I'm going to be using a Nano, and I'll explain why in a second. But really the heavy lifting in terms of data is going to be done by the ESP32, which streams it across. This is a very simple explanation. Streams it across to the VS1053. It decodes the information as MP3 data and kicks it out over that little 3.5mm jack. Sadly, there isn't just sort of like some pins to pull that out from, but we'll just use a little cable. And then we're going to kick it into the PAM8403. Now the Nano is going to do something else. Let's have a little look at what that's going to be doing. So the Roberts RM20 is like a medium wave and long wave radio. Currently, it doesn't have any guts in it. That's because this thing was my Raspberry Pi internet radio, which I used for a long time, but it was a bit of a pain to use because it takes a while to load up and you have to safely shut it down, which I did with these buttons. And you'll notice because I've used it for a while, all the caps have come off, but I've got them, so I'm going to glue them back on. I would like to reuse one of the things that I did before, which was using this dial. And I did that with a Nano. So I was reading the variable capacitor that's in here. Let me show you. That's why we've got these wires hanging off. That is the variable capacitor. I think it's a double wipe capacitor. So when you click on the medium wave and long wave, I think it switches to the other one. So we don't need to connect to both. We only need to connect to one side. So yeah, we're going to reuse that, hopefully. I say we're. I mean, it's mainly me. But there's also something cool in here. Let me turn my power supply on. And I'll turn this on. So this is there's a little incandescent bulb similar to this one in there. It's a Mez bulb or a micro Edison screw, I think. And it's quite nice, isn't it? Let me just turn the power supply on and off. So it looks really good, and when it was mains powered, this is what it would look like at 6.5 volts. However, I'm going to be running my ESP and all the rest of it from 5 volts. So it's going to look more like that, which you can barely see. So I'm going to pick up another bulb and see if we can find one that's a lower voltage that I can deal with. And then I can have the Nano control whether that's on or off. Right, let's have a look at Nick's example on Educates.tv. He's got a schematic diagram and we can have a look at his code as well. So this is Nick's page on Educates.tv. I'll put a link in the description so you can find it. But we can skip a lot of this because he's doing a really detailed description, and I'm going to sort of skip that. I've already watched the video. So he goes and talks about what you need. So I've already paid attention to that and picked it up. And then this is the really important bit, his sort of schematic. So this is the breadboard layout essentially. So here's our ESP32, and this is the MP3 decoder, specifically the VS1053. And we can see all the connections. So I'm going to write those down with the numbers, so it's a bit easier to do. And then we can put it in a breadboard, but he's also got the code in here. So let's just scroll down. Here we go. So if I download the code, right, now we know the basic circuit, we can get rid of Roberts for a minute and bring it in. So this is what we're aiming for. So on this VS1053, you'll notice on the back, that's where we can find our markings that are listed here. So let's wire it up. Now the names on this make me think it's some kind of an SPI connection, but I'm sure I watched a video by Andreas Spice. I don't know if that's how you meant to say his name. That's how I say it. And I think he was talking about something like an audio-specific SPI. However, I don't need to know how it works, only that it does. Right, hopefully that is everything. I know it looks like a real dog's dinner, but we'll put it on a prototyping board or something shortly. Here's the code that he's using. Now, I'm not going to need to use some of the stuff he's got for his Nextian display. In fact, I'm not going to be using a display at all. So, okay, so it looks pretty straightforward. He's commented stuff, which is nice. So here's the bit about 32 bytes. I think I might have said kilobytes earlier, I didn't mean to. And this is where the streams go. Okay, what I'm going to do is I will strip out everything I don't think I need, and we'll go with something very basic. So he's got interrupts for the next station and the previous station. I don't need those. We're going to be triggering it in a different way. And so we've got initiate MP3 decoder, connect to Wi-Fi, read from EEPROM. I'm not going to be using EEPROM. This is the constructor for the VS1053 from Player. So we're going to need to get this library here, Baldram. So we'll have to pick that up and download it. I don't know if it's in the Sketches sort of auto install thing. Let's try. Not by the same person. So I will get this one because I know that's how this one works. But there is an Adafruit one, so maybe that's a possibility. Essentially all we're doing is here is in the loop, we're reading a chunk of data and then sending it to the player. So the ESP32 is just sending it data, so just the same way that any of those libraries probably do it. So we might be able to do it with another library, but we'll use this one because I know it works because I've seen Nick's video. Right, so I'm going to pare back this code very quickly and get rid of everything we don't need for a basic setup. So we're going to remove the EEPROM stuff and get rid of the EEPROM size. And let's get rid of the autosave. And we don't need the buttons either. So we can remove these button functions. EEPROM we can remove. And the button statements there. And these. And that there can go. Now the idea is that I'm paring this back to the most simple example possible, and that should make it easier for me to understand what's going on here. So it looks like this if statement here inside the loop is going to print out how many seconds the radio station, how many seconds the player has decoded. And it is also setting the station if it isn't the previous radio station, so if that station changes. Now station connect we've got to keep, but we can get rid of the Nextian commands. Connect to Wi-Fi will also keep. Initiate MP3 decoder will also keep. We can get rid of the Nextian thing there, and draw radio station, that does not need to be there anymore. Read from EEPROM we can remove, write EEPROM we can remove, and reset module, I don't know what that is, so we're going to remove it. We can always put it back. So that looks like it is the basic thing that we need. So this is everything. I'm going to reduce the volume just in case that's huge. It is the top level, and hopefully we'll be able to compile that Let's see. Well, it looks like it compiles. Doesn't mean it's going to work, but let's upload it to our board now that we've got our sort of basic circuit breadboarded up, and see if we can hear anything. Again, we might need to change these radio stations, but we'll leave it as this for now. Now, I've put my internet credentials in there, so it should work straight away. Let's get some power on the go. Right, fingers crossed. If not, we're going to have to look at the serial output to see what's wrong. It should automatically play. I don't know how loud it's going to be. Right, I'm not sure how I'm going to cut this, but it did just work. However, it played some music, so I've had to go over and switch the radio station out for Radio 4, where hopefully people will just be talking. We'll see. So let me plug it back in. Hopefully I can put a bit of it working first time in. It's very rare that that happens. Now it should take a couple of seconds just to connect to my Wi-Fi.
If I drive somewhere where I might get some service, whoever it is could be gone.
There we go.
And maybe that Henry's come home. I think we have the only other key.
Perfect. So that is absolutely fantastic. Look how simple that is just to put together. I guess it's a simple process that it goes off to the internet, pulls in 32 bytes of data and sends it off to the VS1053. However, we've got to do the complex bit now, which is integrated into existing hardware, which is my Roberts radio. For that, we're going to be using the Nano, and we're going to use a PAM8403. Now, it's not going to sound as nice as this speaker, but it will sound all right. I don't imagine the Roberts RM20 actually sounded all that good in the first place. So the setup for the Nano is pretty simple. We've just got two connections to start with. We'll think about that LED a bit later on. But we've got A0, and that goes to the yellow wire, and the other one goes to the black wire. And we're talking about this here. This variable capacitor connected to this wheel. Now that wheel is connected to the tuning dial on the front. If you can see, I can move that by turning the dial. Now that's a variable capacitor, and we just need to plug it into here. So let's do that now. We've got a 0, and that goes to the red wire. Although I don't think it matters. I think it goes the other way, and then we've got a 4. Now those are two analog pins, and what's happening is it's charging and discharging it and seeing how long it takes. So I'll plug it in, and then we'll jump over to the code so you can see what's happening on the serial monitor as I turn that dial. Just quickly so you can see what it looks like on the front. You can see I've mapped out stations from the very start, and then as we hit each new one, so that's Radio 3, but I'm going to use that as Radio 6. We've got Radio 1 just there. A bit further on we've got Radio 4, and then we should have another one there and another one there. You can see that's what we're doing. We're just kicking out serial data. Now this was a serial write before, so I'm going to put it back to that. I can't remember why that made a difference. We'll just upload it. You'll see that it doesn't really display in the monitor very well. But let's run through the code very quickly. So this is actually a combination of two different sources of information. So one of them is this. It's a article on the Instructables by Braulio777. His method here for reading capacitance is better than the example on the Arduino website. It's really, really good. In fact, it works very, very well. So I've stripped it back because he used a display and I didn't need that. So props to him. He has a paste bin link. So this is the code he's got, but I've had to take out everything I didn't need, but it works so well. And then all I did was couple that with one of the Arduino code examples for smoothing. So there's a lot of stuff that goes on with capacitors, especially when they're really small and you've got wires trailing all about the place. So it sort of varies a bit. And we're dealing with very small levels of capacitance. So any kind of variation means the time changes and it sort of bounces around. So I'm smoothing the output. So we've got readings, which is an array that's going to hold all of our readings. We're doing 50 and then taking the average. So at the very beginning, that average is really sort of low, and I only act when we get to the end of the readings and divide those down. So you can see here we've got all the bits for the input, output, the cap. And so this is sort of beyond me, like I don't really understand how it works. I know what the calculation is because it's down here. So it's the time taken times the maximum ADC value. So I don't really know how that works, but it does work very well. So thank you very much, Breadboard 777. So we're going through this, and all of this bit here is just us calculating the averages. So at the end of read index 49, we look at our average value and say, is 12 less than the average, and is average less than 18? So it gives us that range, that bit to be between. There is a bit of hysteresis in this circuit, so there's a bit of bounce back and there's a bit of wobble. So if you were to get in between two stations, it can jump around. So we have a gap between them. So there's a gap between 18 and 23, and there's a gap between 31 and 38. And that's to minimize any kind of disruption when you're going between them, so any overshoot. And you can see that we say announce station 1, and then I've just commented with what that station should be, but it has no meaning for the ESP32 or the Raspberry Pi that this was doing at the time, because it decides what 1 is. So if we go down to announce station is just a void function, brings in the station number, looks at the previous station, and if it isn't the station number, then it will announce it. So what I mean by announce is by send it out over serial to the Raspberry Pi, or now the ESP32. And then it puts the previous station number into station, vice versa. But we don't want to do anything with station 0. So I wanted to have a dead zone with this. So it wouldn't say anything if it was station 0, but we could change that if we wanted to. So if we wanted to have an in-between stations noise, like a shh, then I could put something in, maybe put an MP3 on an SD card. But it's quite an annoying sound, so I decided against it. So that is the capacitance meter. Great bit of coding by Breadboard 777. So super appreciate that, and the code from the Arduino website. Now I guess we need to code up the ESP32 to read that serial input. So here's the web radio code, and what we're going to do in the beginning of loop, we're just going to create an if statement, and that if statement is just going to look for anything coming over the serial. Available, and is available is greater than 0. It's not a byte, is it? Let's just call it data. And serial dot read. We're only sending one character at a time. And then I guess we can just print that out, but we'll probably want to do something with it. So whether that's we could do a switch statement. In fact, that's probably a good idea to do a switch statement so that we can action it, or rather set our radio station number. If you see here, if radio station is not equal to previous radio station, then we do station connect. So we can let the code do its work for us. So let's put a switch statement in. I'm not going to remember the case for this. It is case though. Do you know what? I'm not going to type all this out while you're watching, so I'll come back in a second. Right, there we go. So I've written a switch statement. I've realised though that we're going to have to use serial 2 if we want to monitor what's going on, because we're sort of sending and receiving information on the serial port, but we're printing to the serial port as well. I think it's going to be easier just to use the second serial. So that's what we'll do. I've also created an array of the station names. So I know what they are based on the code in the capacitance meter. Although that one was Radio Caroline, but it isn't anymore because I can't get a reliable stream for that. So I've just gone for a talk-based thing. So that's what I'm going for. So BBC 6 Music is going to be my default, so that's 0. We do need to put the URLs in here. I've just put Radio 4 in for now. In fact, give me a second, I'll do that. Right, so we've got all our radio stations in there now. So I've gone out onto the internet and found all the streams. And that should work. So if it receives a number across the serial 2, that's RX2, it should change the station we're listening to. One thing I also want to do while I'm here is just make some changes to Station Connect. So I've had some issues with HTTP 1.1 because it sometimes sends information out in chunks of data, and so that you might not get enough. So we're just going to change to 1.1, but I'm also going to add in a user agent. Now, it's not entirely necessary, but if it thinks it's talking to a genuine internet browser rather than a machine, if you have to connect and reconnect a bunch of times, it might not kick you off or put you on some kind of list for being a dodgy connection. I don't know that for certain, but I know that's happened to me in the past when I've tried to do some web connections. If it didn't see a user agent, then it wouldn't let you do it. So we'll just put Mozilla in. And I'm going to add a short delay. Not very long, just like half a second. And let's give it some feedback. So I probably don't want... I can probably come down and do this. So if that is connected, let's get rid of that. And we'll give it an else. There we go, that's better. Else. Cannot connect to station. Right, we'll change this to be our ESP32, which isn't connected at the moment, but it doesn't mean we can't compile it. And then that should be everything we need to do for now. It might be actually in total. If this works, oh dear. Phew, looks like I've just missed out a curly bracket. Let's try that. Yeah, done compiling. Okay, let's upload it. And then we'll see if we can hook it up to the Nano and change radio stations. To hook up the Nano to the ESP32, we're going to need to step down the voltage a bit because it's going to be kicking out a 5 volt signal. This one's going to be expecting a 3.3 volt one. Now, they might be 5 volt tolerant, but I don't know. So I'm just going to play it safe and use a couple of resistors. It's easy. So this is essentially what we're going to do. We're going to take TX from the Nano, and we'll go through a resistor. I'll figure out what these values are in a second. but this is what a voltage divider looks like. And then it goes to the RX of the ESP. Let me just go away and calculate what those values can be based off the resistors I've got available. So I've got some resistors. I've got a 4K7 and, well, 4.7K and an 8.2, and I've just mixed them up so I don't know which one's which. That is my 8.2. So 8.2 is going to be here, 8.2K, and then that one's going to be our 4.7. Right, so where's the other one? There we are. So that's our 4.7, that's our 8.2. I'll just quickly wire that up and then we can feed it into the RX of the ESP32. Okay, done. So hopefully when we turn the dial up here, we should be able to change the radio station. Let's find out. So I'll just turn this on, the speaker, and I'll get a power bank. I've just moved a few things around. Hopefully when we plug this in, we should be able to tune our radio station with the tuning dial up here. So let's find out. We might have to cut the audio a little bit because might be some copyright issues, but I'll let you know if I do that.
Now you, I trusted you above everyone.
Well, we've got a radio station starting already.
Absolute truth and honor.
As if I can go wrong.
It's totally working. Let's skip back to Radio 4 because I'm most likely to get a strike. Oh my god, this is cool. Right, so basically this is what I had with my, let's stop that. This is what I had working with my Raspberry Pi, except for the startup in this is like basically immediate and tuning's very, very quick. And I can just power it down without worrying about SD card corruption. So that's brilliant. Next step is putting the PAM8403 on. Now there's actually a bit of a difficulty with this because we've got one speaker in here. This is stereo. So we need to somehow sum that stereo signal to a mono signal. But I don't like doing it with, like, you can just do it with a couple of resistors and bring that signal together. But you kind of get some weird distortion sometimes. So I think I'm going to look at a software solution. I think I might be able to figure it out with the VS1053. So I'll go away and look that up. In the library that I'm using, there isn't an option for that. So we might have to modify the library a little bit, which does create complications down the road if you update the library and when you want to change the code for this. But whatever, it'll just have one channel or something. So we'll use this, and we'll also get the light working. So remember, it has got a light in here. I'm going to power it from a separate power source at the moment because I can't find a 3.3 volt regulator that will give me 300 milliamps. The one on the Nano won't do it, and I don't want to go stealing power from the ESP32. So I'd rather it come from the 5 volt line. We'll make a little power supply board up on VeraBoard. And if all of that works, the next bit will be, well, we'll do the code bit for changing the library if I'm able to figure it out. And the next bit will be putting it all on sort of perf board. So looking through the header file for this library, there doesn't seem to be a method for changing from stereo to mono. So some kind of like mix down. We've got start song, play chunk, stop song. Set balance is volume left and right, so it's not mixing. So yeah, it doesn't look like it is an option. Right, after some frantic Googling, I've actually, there's an issue on that, on the actual library, but it doesn't have anything to do with this. Someone's saying he's got problems with his code, but one of the results here, one of the suggestions is, can you test only mono output? So that is writing these registers. And I've just had a look on the VSLI website, and yeah, those registers will do it. So I just need to find somewhere to put that. So I'll have to open a CPP file and throw it in. So CPP file, let's have you open. Okay, so where are we going to put it? Well, what do we do in the code? So we do use begin and switch to MP3 mode are the two things that happen first. So let's have a look at begin. God, there's a lot going on in there. But they are using write register. What's in MP3 mode? Where are you? Soft reset, print details, switch to MP3 mode. So they're doing write RAM and then a soft reset. We could do it in there. Okay, I'm just going to pop it in after the delay here. So it's right. Oh, God, VS Code, you're brilliant. And then it's 0x06. They put a delay in there after writing the WRAM, whatever that is. So let's put another one in. Okay, and save. That should do it. We'll have to re-upload to the board so that it recompiles, but that should work for turning it into a mono signal. Well, we'll see if it has any kind of distortion, I guess. I've quickly made a change to the sort of our capacitance stuff because we want it to play with that light bulb. So I've just put it on a pin, what was it, pin 5, so tuning bulb. So I've just created just your standard stuff for putting a pin high, and we're just going to throw a transistor on there, I think. So what I've done is in the announce station function at the end, I've added turning light. I've created a function called tuning light, not turning light, sorry, misreading. And it's just true and false in those different scenarios. So when you're not on a station, when it's 0, that's at the in between the no man's land bit, then it turns the light off. But when you land on a station and it's communicating that with ESP32, then it lights up. So you've got an indicator that you're in the right place. It's hard to read some of those, the text on that tuning dial. Right, let's go throw all this together. Right, it's time to get all this on perf board. I've made a start, so I've taken out the assembly, the tuning dial bit, and I have soldered on a connector for the light and also for that capacitor so that we can plug these onto the perf board. And need to figure out the power. So what I'm going to do is create myself a little power board with a regulator on there for the 3.3 volts, which is going to go into the light bulb that's in here. So this bad boy there. So I found a 3.5 volt incandescent bulb, so that will do. We'll also have 5 volts coming in via USB, and that will go into V-in on these two boards. So look forward to a nice little time lapse. I might put some music on it. So this is an interesting tool. It's for messing about with Breadboard. There we go. This is it from Farnell, and it's like a weird screwdriver with like blades that cut. And so in your Breadboard, you just sort of jam it in the hole, turn a few times, and it cuts the track. Oh. Love it. It was only a few pounds. And check this out. So I bought a little fiberglass pencil, it's called. You see that area that I've just sort of cleaned? I'll just clean another one now. So I should have done that to start with, really. This thing's great. So this mess is almost complete. We've got the Nano board here. This is complete. So we've got connections for the capacitor, for power, for the bulb. We've got a FQP, some kind of MOSFET. I've forgotten the name. I think it's an N-channel one. And we've got our voltage divider with our TX going over to the ESP32 board, which is what I'm starting on now. So what I've done is I've put some headers on this board so that I don't need to solder to the VS1053. What I can do is just take the board and slot it in like that. And that way I can take everything apart. It's kind of modular. So now I just need to route some wires around to the correct connections on here. Luckily, I still have this, so I won't forget. And then that is it, really. What I'm going to do is mount it onto the backboard that the radio has, and that'll be it. That'll be everything, and then we can try it out. Right, so we're done, I think. I just need to screw it all together. So what we've got here is our modular boards. This one's the ESP32, the VS1053, and our Nano. And everything is all sort of plugged in. Here's my power board, it's just going to sit on the side there. And this is the back panel. So this is just the normal back panel. It's warped a bit, probably got a bit damp at some point. Probably could warp it back, but essentially I've bolted my two boards into the back here, making use of the holes that were already there. And my volume control, because I can't use the volume control on here. Oh, incidentally, I've had to make an addition. So on some of the channels where there's, when it's quieter, I could hear some sort of switching noise, and that was carried through from the USB. So I've thrown on a little audio transformer onto the two signals, so that's the right channel and the shield stuff, the ground, and that's gotten rid of it, which is great. So that goes on the back here, just there, and then the whole thing sort of just slots in the back. Alive and well with a sizable digital footprint. Here, have a look at it. And then we can use the tuning dial on the front. Oh, I've not put the knobs back on the front. I'll show you it in its full glory, but essentially that is the finished board. So just a couple of fairly simple things I've had to do there. Really, it's just Educate.tv's fine work, and the guy that created the library for the 1053. Absolutely brilliant. Well, there we go, all done. Just need to put the screws in the back. I've drilled some new holes because the back sits a bit differently since it's warped. But I only need a couple of screws to hold this back plate on. It's not actually going to be sort of holding much other than the electronics. which are now like sort of obscuring all of the cooling holes. There we go. So I've put the covers on the dials, well, the knobs and the buttons. So it's actually looking pretty nice now. Do you want to see how much current it draws? Let's have a little look. I've got one of these readers here.
Love growing food and fresh
There we
food
go.
and
So
eating.
about half an amp.
I believe that, whether you like fresh food or not, I've never met a person who's allergic to money.
So what do you think? I absolutely love it. It's beautiful, isn't it? Not that that's any of my fault. That's all down to Roberts, who made the thing. But the ESP32 side of the VS1053, thank you very much to all the people that did tutorials on the internet, because I wouldn't have known how to do that. So thanks. Hopefully I've added a little something to the internet by talking about sort of detecting the tuning and stuff like that. Anyway, I love it. So I like old radios. I like modifying them a bit. So this one is a Roberts RM20. All I did was add a line in to that one, and then I've got this one, no idea what it is, RGD, but I made it a Bluetooth radio. It's actually a valve radio, so it's got a bunch of valves in, but it's got some missing as well, so it does not work. Anyway, hope you enjoyed that. I'll speak to you again soon.